Here's an example that requires long division. You can't do synthetic division on this one. And we're finding slant asymptotes, so the power of the top and the power of the bottom, the degree of the top and the degree of the bottom have to be 1 apart, and the top has to be bigger than the bottom. And this is where this applies. And the thing that makes this one hard is they don't give you a term for each spot. In other words, you have to have an x squared minus 2x plus 0 if you want everything to line up correctly, because you've got your x squared, your x, and your no x term, your constant term. And then same thing on the other one. If you want the terms to all line up properly so you can add like terms, you have to put x to the third plus 0x to the second plus 0x, and then you can put your constant minus 1. And now we're dividing 3 things into 3 things is the minimum we can divide into, and we're going to put our first answer here, our second answer here, and then you don't even have to figure out the remainder at that point. You could just focus on the top, because that is going to be your slant asymptote. Our first part of our quotient will be right here, and what we want to do is figure out what could I write in that red underline so that when I multiply it by x squared, I get x to the third. Well, you would just need a single x. And so x times all this, if you distribute it through, is x to the third minus 2x to the second plus, and I go ahead and write 0x just so it lines up with the other terms. Then you draw the line, and my phrase is always draw the line, change the signs, and so I'm going to change colors and change the signs for you across the bottom. And then you can add down, because subtracting is the same thing as adding the opposite, so I just made them all opposite so that I can add down. Then that one should always cross off. Then when we add these, we get 2x squared. When we add these, we get plus or minus 0x. Then we want to bring down the next guy and fill out this spot. So up here, what would we put up in the top to where when we multiply it by x squared, we get 2x squared? So we would need a positive 2. So we're going to put plus 2, and then we're going to multiply the positive 2 by all of the divisor. So we're going to distribute it to 2x squared minus 4x plus 0. Draw the line, change the signs. Then we add down. This should go away, which it does. This is 4x, and this is negative 1. Now, the remainder doesn't really matter, so as soon as you get your last number in your last spot filled in, you could really quit there and not worry about the remainder, because for slant asymptotes, all that matters is the quotient without the remainder. And so this line, which is a slanted line, will be the slant asymptote.